Greetings once again, Pre-Calc students. I'm going to try to record this once again. I've been goofed up or thwarted my last couple times by some changes in my program, but that's fine. Here we go. This whole chapter is on polynomials. We're going to be doing some really neat things with them this whole chapter, and we start out with just some basic information here. First of all, this is a polynomial. Poly, of course, from your studies of English means many, so this has many nomials or many terms. And so the degree of this particular polynomial is 2. By a degree, we simply mean what is its highest power. The leading coefficient is 3. Coefficients, of course, are the numbers that are multiplied by variables, and the leading one is simply the one that is multiplied by the term that has that highest degree. Now, by roots and zeros we've studied about before, it would be what x value I put in place of this that would make this whole thing equal to 0. So you can find roots and zeros by factoring, by graphing, that type of thing. We're going to try first of all by doing a little bit of factoring here. I think that will work in this particular case. This is a quadratic. Again, we set it equal to 0 so we can find the values of x that make this thing equal 0. I think this is going to be 3x and x. This is just the FOIL method in reverse here. And I believe we're going to have, in order to get 8 back there, I think we're going to have 4 and 2 here someplace. So let's see, I think it's going to have to be a plus 4 and a minus 2. If you FOIL this out, I won't take the time to do this on the video, but I think you'll see that that does equal my original expression here. What I want to do then is set each of these parts equal to 0. So 3x minus 2 equals 0, and x plus 4 equals 0. And I'll solve each of those parts. Here I'll get 3x equals 2, so x is going to be 2/3. Here, of course, I'll get right away just x equals negative 4. Those are my two zeros or roots, 2/3 or negative 4. We'll be doing a lot of this type of thing in this particular chapter. Alright, we're going on to slide here. Here's something that's really important, something called the fundamental theorem of algebra. And basically it says if you know what the degree is of your polynomial, that's how many roots it has. Polynomial of degree 3 has 3 roots. 5 has 5 roots. Degree 2 has 2 roots. The only catch is some of these roots may be imaginary. Now, this is a helpful little chart that you should write down, I think. This tells you some things about polynomials and how many zeros they have. Now, you can tell the degree of a polynomial by perhaps another horizontal line test. If you can get a horizontal line to cross the function as many times as possible, that tells you the degree. So for instance here, this would be 1, 2, 3. That's why this has a degree of 3, and yet it only has 1 real 0. The other 2 zeros, remember there has to be 3 total, the other 2 zeros must be imaginary. Here's 1, degree 3, and all 3 of the zeros are real, or cross the x-axis. Here's degree 5. Notice you count how many times that line crossed the function, degree 5, and they all happen to be real zeros. Here's a degree 4. I can get a line to cross that 4 times, but no real zeros. It doesn't cross the x-axis. And you can check out the other ones as well. But this is a huge, huge deal. We'll refer to this a lot, not only this chapter, but in chapters to come. Now let's actually do some examples here. Here we're trying to write a polynomial of least degree that has those particular roots, 2, 3i, and negative 3i. Well, if it has those roots, and I'll just jot those down again, so roots of 2, 3i, and negative 3i. What we're going to proceed on with from there is something called factors. Now factors are related to roots, as we'll see. Factors have the variable in them. Factors are things that you can multiply together to get a bigger number, or in our case here, that you can multiply together to get the polynomial. And factors always have, I'm going to change colors here maybe, will always have this form, x minus a 0, or a root. So if you know what the roots are, or the zeros, the factors will always be x minus that. So in this case, it'll be x minus 2. In this case, x minus 3i, and x plus 3i. So there are my factors. Now I want to get to a polynomial, so that means that I'm going to have to multiply these together. So let's talk about how to do that. I think first of all I'm going to multiply these together, and let's just FOIL this out a little bit. So notice x times x is x squared. I'll just kind of draw it out here. X times x is x squared. X times 3i is plus 3ix. Then I do the same thing with this term. Negative 3i times x is minus 3ix. And negative 3i times plus 3i is minus 9i squared. Well, I think you can see that these two guys are going to cancel out. So I'll end up with x squared minus 9i squared. Now I know you studied about this before, but what do you remember about I squared? Well, I squared is actually equal to negative 1. So if I put a negative 1 in here, x squared minus 9 times negative 1, that's going to actually turn this into x squared plus 9. So that's kind of a handy thing that happens when you multiply the factors of complex numbers together like that. Now remember, I'm not quite done yet, because now I have to still multiply x minus 2 times that. So x minus 2 times x squared plus 9. So again, I have to FOIL this out. This will give me x cubed plus 9x minus 2x squared and minus 18. And just to kind of clear it up a little bit, or clean it up a bit, I'll just put them in descending order in terms of the powers here. And sure enough, there's my answer. So that's a particular polynomial. It has least degree, a degree of 3, that has those 3 roots. So write them as factors, multiply them out, and there you go. Alright, last slide here is just one more example. Find the number of complex roots for that particular polynomial, then find the roots and then graph this thing. Now, we know from that fundamental theorem of algebra, when I see that 3 there, that's telling me that there should be 3 roots. Now, complex, what does that mean? Well, a set of complex numbers really is all-encompassing. It includes all real numbers that we're used to and all imaginary numbers. So basically this is just saying find all the possible roots here. Let's see what we can do here. Now notice one good thing, and if you think back to your days of algebra or something, a good thing to do is do some factoring. And notice that when I have a 6, a negative 3, and a 5, that I have kind of a common factor of 3 out of all that. So I could factor out that 3 and get 2c cubed minus c squared minus 15. Oh, excuse me, I think I made a mistake already, I can see. So notice I can do a quick erasing. Not only do I have a common factor of 3, but I also have a common factor of a c in there, don't I? So I can factor out not only a 3, but a 3c. So then I have 2c squared minus c minus 15. All of that equaling 0. Once again, I can factor this a little bit, I think. So I have 2c and c. And let's see, I think I'm going to need a 5 and a 3 here someplace. See if this is going to work. Yeah, I think this is going to be a minus and a plus. So then I'll get 5c minus 6c, and this should work out. And keep in mind, what I want to do here now is set each of these parts equal to 0. So I set 3c equal to 0, 2c plus 5 equal to 0, and c minus 3 equal to 0. Here I'm going to get c equals 0. Here I have to mess around a little bit, but I'm going to get c equaling negative 5/2, I believe. Here I'm going to get c equals 3. There's my 3 zeros. They all happen to be real zeros here in this case, and so there are my 3 roots. Now we'll talk more in class about how do you find the complex ones if you have to do such a thing there. In fact, one of the things we're doing later on in the unit is something called rootin' for roots, where I'm going to give you a polynomial such as this and ask you to tell me what all the roots are. But probably the one I'm going to give you will have some complex or imaginary roots. We'll talk about how exactly to find that. But this gets you a good start, so thanks for watching, and we'll see you guys in class.